From galaxies and stars, down to atoms and subatomic particles, the very structure of our universe is determined by these numbers. These are the fundamental constants and quantities of the universe. Scientists have come to the shocking realization that each of these numbers has been carefully dialed to an astonishingly precise value, a value that falls within an exceedingly narrow, life-permitting range. If any one of these numbers were altered by even a hair's breadth, no physical, interactive life of any kind could exist anywhere. There'd be no stars, no life, no planets, no chemistry. Consider gravity, for example. The force of gravity is determined by the gravitational constant. If this constant varied by just 1 in 10 to the 60th parts, none of us would exist. To understand how exceedingly narrow this life-permitting range is, imagine a dial divided into 10 to the 60th increments. To get a handle on how many tiny points on the dial this is, compare it to the number of cells in your body, or the number of seconds that have ticked by since time began. If the gravitational constant had been out of tune by just one of these infinitesimally small increments, the universe would either have expanded and thinned out so rapidly that no stars could form and life couldn't exist, or it would have collapsed back on itself with the same result: no stars, no planets, and no life. Or consider the expansion rate of the universe. This is driven by the cosmological constant. A change in its value by a mere 1 part in 10 to the 120th parts would cause the universe to expand too rapidly or too slowly. In either case, the universe would, again, be life-prohibiting. Or another example of fine-tuning. If the mass and energy of the early universe were not evenly distributed to an incomprehensible precision of 1 part in 10 to the 10 to the 123rd, the universe would be hostile to life of any kind. The fact is, our universe permits physical, interactive life only because these, and many other numbers, have been independently and exquisitely balanced on a razor's edge. Wherever physicists look, they see examples of fine-tuning. The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. If anyone claims not to be surprised by the special features that the universe has, he's hiding his head in the sand. These special features are surprising and unlikely. What is the best explanation for this astounding phenomenon? There are 3 live options. The fine-tuning of the universe is due to either physical necessity, chance, or design. Which of these options is the most plausible? According to this alternative, the universe must be life-permitting. The precise values of these constants and quantities could not be otherwise. But is this plausible? Is a life-prohibiting universe impossible? Far from it. It's not only possible, it's far more likely than a life-permitting universe. The constants and quantities are not determined by the laws of nature. There's no reason or evidence to suggest that fine-tuning is necessary. How about chance? Did we just get really, 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 really lucky? No. The probabilities involved are so ridiculously remote as to put the fine-tuning well beyond the reach of chance. So, in an effort to keep this option alive, some have gone beyond empirical science and opted for a more speculative approach, known as the multiverse. They imagine a universe generator that cranks out such a vast number of universes that, odds are, life-permitting universes will eventually pop out. However, there's no scientific evidence for the existence of this multiverse. It cannot be detected, observed, measured, or proved. And the universe generator itself would require an enormous amount of fine-tuning. Furthermore, small patches of order are far more probable than big ones. So the most probable observable universe would be a small one, inhabited by a single, simple observer. But what we actually observe is the very thing that we should least expect: a vast, spectacularly complex, highly ordered universe, inhabited by billions of other observers. So even if the multiverse existed, which is a moot point, it wouldn't do anything to explain the fine-tuning. Given the implausibility of physical necessity or chance, the best explanation for why the universe is fine-tuned for life may very well be it was designed that way. A common-sense interpretation of the facts suggests that a superintellect monkeyed with physics, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. There is for me powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge.
Regardless of whether or not they believe in God, most scientists agree the cosmic code appears to exist.
Everything in the universe is determined by the fundamental forces of nature. The strengths of those forces are characterized by numbers called fundamental constants that are so sensitive that if they changed by just a little bit, the universe as we know it wouldn't be here. For example, if the rate of expansion of the universe right after the Big Bang had changed by 1 part in a quintillion is 1 with 18 zeros after it, the universe would continue to expand or collapse back on itself, and none of this would be possible. To illustrate just how small a number 1 part in a quintillion is, imagine all the grains of sand on this beach. In fact, imagine all the grains of sand in all the world's beaches. That number's probably somewhere around a quintillion. In this analogy, if all that sand represented the rate of expansion of the universe right after the Big Bang, how many grains of sand would I need to add or subtract to wreck the universe? Just 1 grain, 1 in a quintillion. That's how precise things had to be for us to be here.
But even though the Big Bang was perfectly calibrated, intelligent life would never have formed if matter had spread evenly across the universe.
Had it been perfectly smooth, then there wouldn't be any clumps which would gravitate and form stars and galaxies. So we needed slight irregularities in the distribution of matter in the universe. Had those irregularities been much smaller, stars and galaxies wouldn't have formed. Had they been much larger, everything would have collapsed to form black holes.
But even with the right distribution of matter throughout the universe, life would still never have formed without a complex series of processes inside stars that converted helium and hydrogen into heavier elements like carbon that form the basis of all living beings.
Some of those stars explode, providing raw material with which to form new stars, planets, and ultimately life. Had the laws of physics been a little bit different, or even if the physical constants had been a little bit different from what they really are, this process of nuclear fusion and the explosion of stars might not have been possible, and we wouldn't be here discussing it.
I don't know a single scientist who would disagree with the statement that the world is exceedingly ingenious. Not just mathematical, not just beautiful, not just elegant, but the manifestation of something truly extraordinary.
It looks in some respects as though our universe is rather special. We know the universe allowed our emergence, but it's quite easy to imagine a universe with slightly different properties, in which neither we nor anything as complicated as us could exist. We can imagine, as it were, turning the knobs, which were set up at the time of the Big Bang to determine how it expanded and what it was made of. And if we turn the knobs very slightly, we find that we would end up with a universe that would not be so propitious for the emergence of life.
Take gravity, perhaps the most familiar of the laws of nature. Its value determines how much things are attracted to each other. From us being stuck to the Earth circling our sun, to the stars held in place in remote galaxies billions of light years away. Just the tiniest adjustment to the value of gravity in a computer simulation of the Big Bang, and our universe doesn't emerge at all.
For example, if gravity were very strong, then anything as big as us would get crushed. If there were no gravity at all, then no stars would be able to form because they're held together by gravity. No planets either.
And the other laws are equally fine-tuned. Any slight adjustment to their value, and we would never exist. There is no known reason why these values should be set as they are, yet they do seem to be fine-tuned to allow our creation.
To some of us, not all, to some of us, it looks like we have to live with the idea that the constants of nature, the laws of nature, everything that we know about, somehow was influenced by our own existence. This is something which physicists hate the idea of. Most physicists want the world to be controlled by pure mathematics, not by our own existence.
For a while, mainstream cosmologists were content that once we understood better the underlying reason for the laws being set as they are, fine-tuning would no longer seem so mystical, and would once again fall within the realms of physics and mathematics.
The general view of this, for most physicists, is that these fine-tunings are largely accidental, that the constants of nature are determined by some mathematical principles which have nothing whatever to do with our existence. Impersonal, mathematical, and we were just incredibly lucky that that mathematics happened to give rise to a universe with all this kind of fine-tuning, just precisely so.
And so the anthropic principle existed as an interesting but eccentric theory. But then, quite unexpectedly, a completely new law of nature was discovered, and our universe relied on this law being so precisely tuned that it seemed no rational theory would ever explain it.
Our universe seems to be defined by a set of numbers which in some sense look special. If we had different numbers, we would end up with a sterile universe. People react to this seeming coincidence in a number of ways. You could say it's the outcome of some kind of design or providence. We could say it's a brute fact we have to accept, because these numbers might be determined by some theory which we haven't yet discovered.
For a while it was possible to believe that the laws of nature were not so precisely set as to require the hand of a creator. But then a completely new fundamental property of the universe was discovered. An anti-gravity force present in space itself. It is called the Cosmological Constant, and when cosmologists calculated its effect on the evolution of the universe, they realized it had to be very finely tuned indeed.
The fine-tunings, how fine-tuned are they? Most of them are 1% sort of things. In other words, if a thing is 1% different, everything gets bad. And a physicist could say, maybe those are just luck. On the other hand, this cosmological constant is tuned to 1 part and 10 to the 120, 120 decimal places. Nobody thinks that's accidental. That is not a reasonable idea, that something is tuned to 120 decimal places just by accident. That's the most extreme example of fine-tuning.
No force in the history of cosmology has ever been discovered to be that finely tuned. The cosmological constant needs to be set to 1 part in a trillion, 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 trillion. Otherwise the universe would be so drastically different that it would be impossible for us to evolve. That the cosmological constant arrived at such a tiny value by chance seemed to be out of the question, but the alternative explanation was also impossible to contemplate.
Physicists did not want to accept the idea that the laws of nature might be controlled by the benevolence of nature. There should be no reason why the luck should just have it that we can exist. It's too much, it's a stretch. It's much too far to stretch.
It seemed that hidden in the laws of nature was a value so precise that it was impossible to deny that our universe was designed. But a designed universe requires the existence of a designer, a notion that even the anthropic scientists did not want to entertain. The scientists were between a rock and a hard place. Their own discoveries were pointing them towards an intelligent designer.
Physicists' dislike of mixing religion into physics. I think they were somewhat afraid that if it was admitted that the reason the world is the way it is has to do with our own existence, that could be hijacked by the creationists, by the intelligent designers. And, of course, what they would say is, yes, we always told you so. There is a benevolent somebody way up high in the universe who created the universe exactly so that we could live. I think physicists shrank at the idea of getting involved in such things.
Since the beginning of time, all the matter in the universe has been governed by precisely balanced laws and constants. During an interview with Robin Collins, a philosopher with degrees in mathematics and physics, Strobel learned how these laws offer compelling evidence for a creator and conspire to make the universe habitable for life.
The laws of physics are balanced on a razor's edge for life to occur. For example, if you didn't have something like gravity that pulled matter together, you would never get planets, you wouldn't get stars, you wouldn't get any complex organisms. If you didn't have the strong nuclear force, there would be nothing to hold protons and neutrons together in the nucleus. And so you wouldn't have any atoms, so no chemistry. If you didn't have the electromagnetic force, you would have no bonding between chemicals. You'd have no light, and the list goes on. So you need all these sorts of fundamental principles have to be in place in order for life to occur. Wipe out one of those principles, wipe out one of those laws, no life.
Strobel learned that life also hinges on the precise strengths and relative values of many different physical constants. One example of this fine-tuning is the force of gravity.
Imagine a ruler divided up into 1-inch increments and then stretched across the entire universe, a distance of some 14 billion light years. For the purposes of illustration, the ruler represents the possible range for gravity. In other words, the setting for the strength of gravity could have been anywhere along the ruler, but it just happens to be situated in exactly the right place so that life is possible. Now, if you were to change the force of gravity by moving the setting just 1 inch compared to the entire width of the universe, the effect on life would be catastrophic.
no large-scale life forms could exist. Anything that was more than the size of a pea would be completely crushed. So you might be able to get life of a very, very primitive sort, such as bacteria, but you could never get conscious.
Is there any scientific basis for thinking our universe may have been created with purpose? John Polkinghorne worked alongside an astronomer who made a critical discovery that shook his beliefs.
One of the great triumphs of astrophysics in the second half of the 20th century was to figure out how the elements are made. Because the very early universe is very simple, it only makes very simple elements. In fact, hydrogen and helium, the two simplest elements, and you can't really do very much with them. They have very boring chemistry. You need much more elements if you're going to have something as interesting as life, and in particular you need carbon. The chemistry of life is the chemistry of carbon. So where does carbon come from? There's only one place in the whole universe where carbon is made. It's made in the interior nuclear furnaces of the stars. Every atom of carbon in our bodies was once inside a star. We're people of stardust. Now, how that happened was figured out in Cambridge. Fred Hoyle, a senior colleague of mine, was one of the leading figures in this. And they were trying to figure out how carbon was made. They had helium, and if they could make 3 heliums stick together, that would make carbon. But they couldn't figure out how to do that. To get 3 small things like that to stick together at once, you can't do it. Okay, so we do it bit by bit, make 2 stick together, that makes beryllium, stays around a bit, another one comes along, makes carbon. But it doesn't work because beryllium is very, very unstable. It just disappears like that. So they were stuck. And then Fred had a good idea, and he said, it'll just go if there is something called a resonance, a very enhanced effect, which is just at the right energy in carbon to make that extra one stick on much, much more quickly than you would have thought. So you're very pleased with myself. We went off the nuclear data tables just to check that this resonance, this effect was there, and it wasn't. And so Fred was a very stubborn persistent friend. He rang up some friends and said, look, you've missed something in carbon. There's a resonance there that you haven't spotted, but I know exactly where it is, so you had to have this energy. And they were apparently a bit reluctant to look, but in the end they went and looked, and they found it. That's a wonderful scientific story. But also it struck Fred that it's more than a scientific story, because, of course, if the laws of nuclear physics had been a tiny bit different, either there would be no resonance at all, or it would be some other energy which would be no good. And Fred, who had a lifelong commitment to atheism, is reported to have said, in the Yorkshire accent, beyond my powers to imitate, the universe is a put-up job. In other words, this can't be just a happy accident. This is too significant for that. There must be something behind all this. Because Fred didn't like the word God, he says some capital I intelligence has monkeyed with the laws of the universe.
Observing the universe, then, can spring riddles for atheism, too. Hoyle's groundbreaking discovery led to what subsequently became known as the anthropic principle.
I can give you one of the most famous examples of that, if you like. And that's due to Fred Hoyle, who was an atheist astrophysicist. Interesting background to Fred Hoyle, because originally he was opposed to the Big Bang because he thought it meant that the universe had an origin, and if it had an origin in time, you might need a god to make it. Now, theologians are, more blasé about that, but Hoyle, as an atheist, was really troubled by that. And he proposed the steady-state theory instead, which was eventually overthrown. And the Big Bang reigns supreme. But Hoyle did some really, really important work on how the chemical elements of which the stars, of the planets, and ultimately us, of what are made. And he discovered that you need a very, very fine balance of the forces in nature in order to make carbon inside stars, which is essential for life, and in order to make oxygen without destroying all the carbon in the process. So two seeming coincidences necessary in order to get the materials for life. And when Hoyle made that discovery, he was moved to remark that a super intellect has monkeyed with physics and with all of chemistry and biology, and that there are no blind forces worth speaking about in nature. It's a put-up job, was the kind of way he expressed it. He was deeply impressed by this, and here you have an atheist, a man who called religion an illusion,
And he said that in books and on TV programs in the early 50s and so on.
Something like this. Premise one, the fine-tuning of the universe for intelligent life is due to either physical necessity, chance, or design. Second premise is it is not due to physical necessity or to chance, from which it follows logically, 3, therefore it is due to design.
So explain number 2. In other words, the universe doesn't have to be beautiful and ordered. Was that what that number 2 is?
That's correct. What scientists have discovered is that from the very moment of the Big Bang, the universe was fine-tuned with literally an incomprehensible precision and delicacy for the existence of intelligent life, such that if these constants or quantities had been altered by less than a hair's breadth, life would have been impossible, and there would be no life of any sort throughout the entire cosmos. And the question is, how do you best explain this appearance of design? Well, physical necessity would say the universe has to be that way. It must be finely tuned. But that is extraordinarily implausible because you see these finely tuned constants and quantities that we're talking about are independent of the laws of nature. They are not determined by nature's laws. They're just arbitrarily put in at the beginning, inexplicably. So they're not physically necessary. Now somebody might say, well, it's just due to chance. It's just a lucky accident. But the problem with that alternative is that it has no appreciation of the fantastic odds that we're talking about here. For example, if the subatomic weak force had been altered by as little as 1 part out of 10 to the 100th power, that's 10 followed by 100 zeros, the universe would not have been life-permitting. And there are a dozen or more of these kinds of constants and quantities, all of which have to fall into this exquisitely narrow range of life-permitting values in order for the universe to be life-permitting. So that the idea that this happened just by chance is just infinitesimally probable.
In fact, I think non-believing statisticians and philosophers have said there hasn't been enough time in that 13.7 billion years for that type of chance to bring about the kind of order that we're seeing.
Right. I mean, to give you an idea of the numbers we're talking about, there have been only around 10 to the 17th power seconds in the history of the universe. And now we're talking about odds like 1 out of 10 to the 100th power. And this is just one parameter, and there are, as I say, many of them.
At some point, certainly, we're all asked, well, which is the best argument you've yet come up against from the other side? And I think every one of us picks the fine-tuning one as the most intriguing.
The Goldilocks.
Yeah.
Okay.
Fine-tuning the 1 degree, well, 1 degree, 1 hair different to nothing. But even though it doesn't prove a designer could all have happened without it. You have to spend time thinking about it and working on it. It's not a trivial. We all say that.
However, even if you give me the greatest success in making that argument, it will only give me a rather limited idea of the nature of God. It will show me a God who is, if you like, the architect of the universe, a God of great power and so on. But there are many other questions we will want to ask about God, because God cares about individual human beings and so on, which won't be answered by that type of argument. So I think it's useful and it's helpful, and I think it's a hint of the divine presence. But that's as far as it goes.
And for me as a Christian, the Christian faith is tremendously important, as it says that you can only know the author of the story on the basis of the author reveals himself in a way that our finite minds can understand. At the heart of my Christian faith is the conviction and the experience that God has revealed himself supremely in the life, death and resurrection of Jesus of Nazareth. And I know what the deeper story is about because I've seen it in Jesus. I know that there's a creator God, and that creator God is a loving God.
And then, as I say, natural theology of this or any other kind only gets you so far. What does it say about God? Well, not all that much. I mean, I think God has to be pretty powerful, and adjectives to do with majesty and so on might apply to the creator of such a vast universe as we've got. But it doesn't get you to the personal God who reveals himself in Jesus Christ, and who actually, most astonishingly of all, becomes one of us, becomes incarnate in Christ, lives a perfect human life, dies for us, and rises again. That story is a different one.
For Graham Swinnard, thinking about fine-tuning was the first step along a pathway that led him to an encounter with God.
I had a very intellectual approach, or head approach to everything, rather than a heart approach to everything. Anyway, so at the end of the day, I went on that, and I learned about the Christianity and the Christian God, and in fact, also as part of this course, I had what you might regard as a spiritual encounter, and that was a real eye-opener for me, because I'd always had I didn't acknowledge any kind of spiritual dimension to life whatsoever prior to that.
So the fine-tuning argument, the intelligibility of the universe, the awe-inspiring nature, the elegance of the physical laws, all of these things are pointers which raise questions for me. But my knowledge and experience of God comes from the fact that I believe that God is a revealing God, and that revelation comes in Jesus.
For centuries, the fact that we can discover things about the universe has really been something of a mystery. Why would beings like ourselves be able to discover a universe like this? Why is what we think about the universe, why would it correspond to the way things really are?
Our ability to discern and understand the universe is a fundamental part of what makes the universe tick, so that we're linked into it. This isn't just a sort of an accident, a trivial little byproduct. It is something that is linked to the great cosmic scheme of things. Now, I've no idea how that linkage works, why it's there, or anything of that sort, but I'm very, very struck by the fact that we can understand the universe in such exquisite detail and at such a deep level.
The spectacular progress of modern astronomy and physics is the product of a universe accessible to the human eye and mind. It is a universe governed by laws and forces that literally hold our planet Earth and the entire cosmos together, and are finely calibrated to allow for both complex life and scientific discovery.
The existence of life on Earth is very delicately balanced in the scales of chance. The list of things that had to come out just right is enormous. Take, for example, the chemical elements. There had to be plenty of oxygen, carbon and hydrogen, but we wouldn't have wanted these things to combine together to make nasty substances like methane or ammonia, such as you find on other planets like Jupiter. Professor Davies adds to the list.
On top of this, there had to be a very narrow range of temperatures, in this case supplied by the sun. This means that the sun has to be very stable and not flap up and down in its temperature, and the orbit of the Earth around it has to be very nearly circular. If gravity were a little weaker, we'd have lost all our atmosphere, like the moon. If it was much stronger, we'd break every time we fell over, and without that layer of ozone above our heads, we'd be exposed to deadly ultraviolet radiation. There's still the fact that the entire universe seems unreasonably suited to the existence of life, almost contrived, we might say a put-up job.
What is at issue concerns the hidden, vital complex of particles and forces, the nuts and bolts of the universe that shape it and hold it in existence. Some of them, like the many so-called constants of the universe, may seem of interest only to those mathematicians, physicists and cosmologists who delight in them. Not so. Unless every element in this underlying foundation interlocked precisely, there would be no universe at all.
It turns out that if you change just a little bit the laws of nature, or you change a little bit the constants of nature, like the charge on the electron, then the way the universe develops is so changed that it's very likely that intelligent life would not be able to develop.
If we nudge one of these constants just a few % in one direction, then stars burn out within 1 million years of their formation. No time for evolution. And if we nudge it just a few % in the other direction, then no elements heavier than helium form. So no carbon, no life, not even any chemistry, no complexity at all. And if we could alter the relative masses of two of the subatomic particles, the proton and the neutron, by just a fraction of a %, atoms would be unstable. There'd be no stars, no light, no warmth, no structure at all, just chaos.
Well, take, for example, the so-called Big Bang, the thing that started the whole universe off. And that just wasn't any old bang. It was an exquisitely orchestrated affair, so that it's precisely uniform as we look around us in space. Now, if that bang had been less powerful, the whole thing would have come out and then collapsed back into a big crunch and gone out of existence long before now. On the other hand, if the bang had been more vigorous, everything would have been flung apart and completely dispersed, and no galaxies would have formed, and we wouldn't be here to talk about it. It turns out that when you look at the rate at which the universe is expanding, it's precisely on the dividing line between these two unpalatable alternatives.
In the 1950s, well before anyone had invented the anthropic principle, Fred Hoyle was working out how the elements of which we are made were created in the nuclear furnaces inside stars. Stars are mainly hydrogen and helium, the simplest atoms of all. For the star to make carbon, 3 of its helium nuclei have to collide. Snooker players will tell you that happens very rarely. Far too rarely for the star to produce all the carbon we need in our bodies. But when 2 helium nuclei combine, if there's another helium close by, something strange happens. It's as if the target gets much fatter. So the likelihood of the 3rd helium homing in on the right spot to make carbon is enormously increased. No other elements behave like this. This unique stroke of utter chance has enabled stars to manufacture enough carbon for our bodies. But that's only half Hoyle's story. If another helium hits the carbon, it'll produce oxygen. So why is there enough carbon left for us? Once more, nature has made a unique and fortunate choice. This time, the reaction is so far off-tune to the energy available that only half the carbon is changed to oxygen. What were Hoyle's conclusions? A common-sense interpretation of the facts suggests that a superintendent has monkeyed with the physics, as well as chemistry and biology, and that there are no blind forces worth speaking about in nature. I do not believe that any physicist who examined the evidence could fail to draw the inference that the laws of nuclear physics have been deliberately designed with regard to the consequences they produce inside stars.